Good morning, Mr. Beach. I wanted to send you this video. I noticed you missed several things in the electrical measurements quiz, and I want to talk about that just a minute. Whenever we're measuring resistance in a circuit, for instance, one of these over here, in parallel, you probably remember that when resistors are paralleled, the resistance, overall resistance gets lower. Now, when they're in series, the overall resistance gets higher. And it's kind of counterintuitive in a sense, but parallel circuits are just like anything in your car. Everything in your car that's electrical runs off of 12 volts DC. So this could be like one headlight, this could be the other. So obviously, if I've got one headlight burned out, I'm not going to be pulling as much current as I would if I had both headlights on. So that's what this picture is actually showing you here is we have total current, which is represented by I up here, and I did not mean to erase that, so let's undo that. Apparently I'm set to erase. So there we go. So let's get home and let's get off of erase so that I don't do that anymore. So we've got total current up here, and it splits between the two. So if this bulb's pulling 10 amps, this bulb's probably pulling about 10 amps too. So my total resistance up here would be 20 amps. Now, if I do need to measure one of these resistors, if I put a meter across this R1 or R2, it really doesn't matter. But if I come in here and, wow, I cannot draw on this tablet. I'm still trying to get used to it. So let's undo that, and let's try this one more time. There we go. So if I come in here and I place a meter right here, and again, sorry about my cruddy drawings, and I'm measuring resistance with that meter, I'm going to measure the resistance of both of these components. But if I come in here and break this circuit right here and have my meter across here, I've got no path to measure that second resistor. I have a really electrically isolated R1 just by breaking that path with by lifting one leg, basically. So you missed a question that says, which of the following statements is not true about measuring the resistance of a component that is connected in a circuit? Turn off the power supply. Definitely want to have no power. Make sure the power supply is not true. Okay, yeah. The correct answer was make sure the power supply is not on, because this is a not true, kind of an inverse thing. We do have to turn off the supply. We do have to disconnect one of the component leads, and we do have to connect the leads of our meter across the component. But the one thing we want to make sure is when we're measuring resistance, we isolate the lead from any other resistance in the circuit, and we do have the supply off, and we're measuring across the component we want to measure. So I'm going to do this, and we're going to look at some of the other items that you missed. If I can make this tablet cooperate, which is proving to be quite fun. All right, current in a blank circuit is divided amongst the branches. Well, remember, in a series circuit, there is only one path for current. Current's like water through a pipe. So if I've got water flowing in this series, whatever current's going through R1 is going to be also going through R2. So the current in a series circuit is always the same. But in a parallel, it's not. Unless, they happen to be, I mentioned the headlights a while ago, those should pull about the same amount of current, but still total current's going to be twice that. But when you look here, if we've got our inside light on, especially a dome light or something like that, compared to a headlight, this headlight's going to pull a lot more current than this dome light over here. So we would still have the total of the two. Let's say this is 10 amps, this is 1 amp. So we would have 11 amps of current coming through before the branch and after the branch. But if this were the dome light, we'd have 1 amp here, we'd have 10 amp here, and we'd have 11 amps on either side past where the split happens. So the answer you had was current in a series circuit is divided, but that's not true. It's actually voltage. Voltage divides in a series, current divides in a parallel. So just want to make sure you understood that and understood why. The only thing that you probably maybe have seen that's kind of close to a series circuit type thing, if you ever mess with Christmas lights, where if one bulb goes out, they all go out. Well, remember, we only have one path for current. So this thing could have 100 bulbs in it, and if one of these bulbs opens up, we have opened the entire circuit. There's no path. So let's say there's 50 bulbs up here and 50 bulbs down here, and if we break this bulb right here, there's no path for it. And so those are all connected in series most of the time with these Christmas lights. Most everything you deal with from an electrical standpoint in your home, on your car, are parallel type circuits. So that's the difference, and that may help you understand the difference between why current is the same in the series and voltage splits across each one. Here, voltage is the same for R1 and R2. They're both seeing and connected to the same source, but they may have and likely will have different currents. And even if they happen to both be, like I said with the bulbs a while ago that were headlights, 10 amps and 10 amps, you would still have 20 amps of current up here. So that's the difference kind of between series and parallel. Another question you missed, potential difference between 2 points in a circuit is called voltage. Voltage is a potential difference. So what that basically means is it's something we can measure. If I can put a meter on this positive side of the source and a negative side of the source and measure a voltage, that is a potential difference. If I can go across this resistor and measure a voltage, there is a potential difference between those 2 points, and that potential difference is voltage. All right, another, when loads are connected in series, their individual resistances are, you chose divided, they're actually added. So if this one is 10 ohms and this one's 20 ohms, our total resistance would be 30 ohms. Here's some kind of rules you can probably remember. In a simple parallel circuit, every branch, we could have 15 more resistors, R1, R2, all the way out to R15. Every branch is going to see the same voltage, but they're going to have their own currents. So everything is connected to this source. So if this source were 12 volts, this would see 12 volts, this would see 12 volts, all the way out to R15, which would see 12 volts. But they're going to have their individual currents, and their currents will add up the total current. Here, we're going to have voltage drops across each of these resistors, but they'll all see the same current here. So that's kind of the difference between, and the sum of these drops, R1 and R2, should equal whatever we're applying. So the individual resistances are added together, and if you remember over there at the trainer when you added a 25 and a 25 and a 10 ohm in series, you got 60 ohms. If you parallel those, you've got to use a different formula to get that, but you're going to have something lower than 10 ohms because resistors in parallel are always lower than the lowest value. So that's one thing to keep in mind as well. All right, number 8 you missed. To measure current through a component, the ammeter must be measured across. The ammeter is the only part of a meter that you have to typically move the leads on, and you have to break the circuit. If I wanted to measure the current just through R2, I'm going to have to break it at some point. I could come right here, and then I could put up 1 meter lead of my meter here, and I could put the other here and insert it. Because remember, we said current is like water through a pipe, not voltage through a pipe, water through a pipe. And to measure water in a pipe, if we want to know how much water is flowing, we've got to cut that pipe and insert an instrument in it. And that's really what an ammeter is. It's measuring the flow of electrons through that circuit. So we have to break that circuit. It's really the only time we have to break a circuit with power on it to measure something. Now we have to remove a lead to measure resistance, but power's off at that point, so it's not an operational circuit at this point. But current, we do have to break the circuit and we have to put it in series with. Basically, the meter becomes part of the circuit, and that's how it's measured. You missed current is measured in units of what? It is amps. Voltage is a potential difference, and like I say, we measure it in volts. Current is flow, and we measure that in amps or amperes. Amps is short for amperes, and you'll rarely, if ever, hear anyone say amperes, but that is the technical thing for it. And resistance is measured in ohms. So, hope this has helped you some. Feel free to stop in. I don't mind going over this with you. This is kind of some basic stuff, but it will serve you throughout your career, and I want to make sure you got it. Also, if you'll come see me, I'll reset that test that you had and let you have a do-over on it. So, bottom line, come see me. We'll get your test reset and give you an opportunity to take it over again. And most of all, if you have any questions, please don't hesitate to contact me or any of the guys here in the lab. They're always eager to serve you. Thank you much.